Okay, we have quite many people here, so let me introduce this workshop, C-Sharp scripting and plugin development for Grasshopper. We'll introduce you. The overall idea is to get you more into the advanced level of using Grasshopper, using programming, more specifically the C-Sharp language, where you can implement a lot of logic and design logic that is not possible with the normal visual programming in Grasshopper. And then you will learn how to make plugin as well. So after you know how to use C# and you have an idea of how to implement certain logic, you can package that kind of code in a little plugin and share it with your friends or the community. So this is something that we start doing in 2015. So every year since 2015, we teach this course to the iTech program. Last year we kind of also live stream it last year because the level of interest into this kind of topic has been increasing over the past few years. This year, for the first time, we decided to offer this course to students other than the iTech Master program. So there are many of you here who are not part of the iTech Master program, and this is also the first time we do this as a credit course. So you will get credit for attending this workshop. Now, for those of you who apply to get credit for this one, you will have to do a little assignment for assessment after this workshop. Okay. So now all the informations will be on the main website. So for the people who watch online, it's important. So if you want to follow the workshop and follow all of the live example, it's important to kind of download the handout, because this is where you have all of the code, the code samples, and here is a list of software and tools that you will need. Now, I'm sure you already have Rhino and Grasshopper. The other tools we don't really need until tomorrow. So if you haven't installed these tools yet, you can do it tonight before you start tomorrow. Okay. So we have 50 people here in the real room. Of course, again, feel free to ask me questions. And for the people who are watching online, you can also ask questions by typing in the comment section on YouTube, and I will look at it and then I will answer if it's possible to do so right away. Now, to help me teach this class, my colleague Fred here will be helping me, and I also enlist the help of one of iTech student, G. Okay. Because there's 50 of you here, and I cannot really handle you guys alone, plus the online live stream. So thanks to these two people. Okay. So all of the so everything will be recorded and everything will be live streamed, and the live stream video will remain available on YouTube. So if you want to rewatch this to refresh yourself, you can still do it. As the iTech students already know that I always record all of my lectures and make it online so everybody can rewatch. So don't worry about if you miss something or something that you're not so sure and you want to revisit. It will be there. Okay. Yes. No, I would say so. Rhino 6 is preferred, but Rhino 5 is still workable. Just Rhino 6, you will get much kind of nicer looking result, and it runs a bit faster, slightly faster. Okay. Oh, okay. All right. Yeah, well, Rhino 5 should be fine. So no worry. Okay. So let's get started. So this workshop, this actually workshop / course, because it's kind of half workshop, half course, a seminar. So the overall aims is to teach you the C# language. Now, probably more than half of you here already know at least one programming language, namely Python. This one introduces you an additional, very useful language for the field of architecture. So, and then for those of you who already have an idea of what object-oriented programming is, this course will, give you more knowledge on that. But we're gonna also start from the quite basic of object-oriented programming. It's like when you program these days, it's impossible to avoid learning some object-oriented programming techniques. Now, the most important thing is that we will go beyond the visual scripting approach in Grasshopper by writing programming code in C#. This will allow you to implement certain logic that is not possible or extremely inefficient to achieve with just the visual programming in Grasshopper. You will become familiar with the Rhino Common Library. So the Rhino Common Library is the programming library where we will use to access all the features of the Rhino geometry engines, both in Grasshopper and in Rhino. The workshop will also improve your programming skills in general, okay? So all of these skills apply equally, not just to Grasshopper and Rhino, but like when you program in general in all the software or like in any project. And then you're gonna learn how to use this little nice tool called, well, it's not little, it's actually a very massive tool suite called Visual Studio. It is a special software that you will need to install for tomorrow. This is the software that many, well, I would say the majority of professional software developers for the Windows platform used to make software, okay? And we're gonna make plugins for Grasshopper, which basically a piece of software. So we're gonna use this Visual Studio, which is like a really powerful tool set, and Microsoft make it free for non-commercial use. Of course, one of the biggest goals is to learn how to make plugin for Grasshopper. Okay. So the overall agenda for the 3 days is as follows. So today we're gonna get into the basic of the C# programming language. Okay. And then we're gonna, so for today, all of the code that we're gonna type is going to take place inside Grasshopper. Okay, we're not going to type the code in any other software. Everything will take place inside Grasshopper today. And then we're gonna start to learn a little bit about the Rhino Common geometry. This is the programming library where we can use C# or Python. For those of you who have learned the Python seminar, who took the Python seminar before, you learn how to use R and Python to access the Rhino Common Library, where you can get into the point, the vector, the curve, the mesh objects of the core Rhino geometry engines. And then at the end of today, we're gonna do a little live hand-on exercise. We're gonna do circle relaxation and curve subdivision growth. So I can show you what that live example gonna look like, and you're gonna probably see why this kind of geometry is a problem is not possible to achieve with Grasshopper alone. So this is an abstract geometry problem, but you can think, you can apply kind of many principle and technique to solve kind of many constraint-based design problems. So let's say that if you want to generate a very complicated curve that pack itself as much as possible, but should not never cross itself, never self-intersect. So at the end today, this is what we do. We start with a simple curve, and then we're gonna grow this curve like iteratively. And each time it curves, we will try to pack around itself as much as possible, so the gap is kind of uniform, but you see it would never intersect itself. And imagine you can use this to generate some kind of path or like planning or like zoning, for example, where the condition is that everything has to be like maintain a certain uniform gap, and it's packed as efficiently as possible, but should not self-intersect. Okay. All right, and so that is hopefully the end of today. We're gonna achieve that. This is the first time I do this with 50 people, so let's see if we can manage to do that. Okay. So now on the second day, we're gonna jump into Visual Studio. So we're gonna start learning this new tool set called Visual Studio, where we're gonna write C# code, and the C# code will be compiled into a .gha file. The .gha file is the file that contains the Grasshopper plugin, right? And the .gha file you can install to your Rhino or to Grasshopper, and then it will act as a plugin. Now the logic inside the plugin will basically just implement using C#. So the idea of plugin is just more about packaging so that you can share, distribute easily. But the core logic is still pretty much the same based on what we learned from the first day, for example. Okay, and then we're gonna do object-oriented programming. So you learn a concept about classes, which is very important. Like object-oriented programming is useful to understand how the Rhino Common Library is structured, and not just the Rhino Common Library, but pretty much these days when you program with anything, you work with any library, it's going to be object-oriented anyway. Okay, if you haven't never heard of this term before, don't worry, it will be explained on the second day. And then more on the geometric and design aspect, we're going to focus on the mesh in Rhino. In fact, we're going to do two types of mesh, the Rhino mesh and the Plankton mesh. So Plankton is a different type of mesh that comes with the plugin Kangaroo 1 for Grasshopper, and Plankton mesh offer a lot of advantage over the default mesh system in Rhino. So we're going to we're going to learn both, but then we're going to use Plankton mesh to do this major programming exercise. Basically, we're going to grow a mesh based on subdivision and self-intersection avoidance. So it's similar. So this one is a 3D version of the curve subdivision growth. So this one is a 2D version, and this one is more like a 3D version. Where now the nice thing about this one, let me show you a video first of what we're gonna kind of achieve at that point. Okay, so we start with like a simple triangular mesh. You don't see the triangular face here, but these are the surfaces made out of triangles. And the triangles get larger, but as they get larger, if the edge get too large, they will be split into two edges. And as they push each other away, they will have to avoid intersecting with themselves. And because they have to avoid intersecting with themselves, they have to curve around themselves, And this makes simple mechanism, it's conceptually simple, but of course it's not simple to actually implement. Will create this rather intricate geometry where you have a surface that's splitting, and go around each other, but should not never collide or cut into itself. Okay, and this kind of mimic the process of many surfaces in nature. So if you look at the kale leaf, or flowers, or the wrinkle or the crease on your brain, it's kind of a similar principle where you start with a small surface and then the surface grow larger, and as the surface grow larger, the surface has to push itself in, and because in real life things cannot go through each other, it has to like wrinkle and pack around. Now of course in computer it's making things not cut into each other is the hard part, right? Because normally when you model, everything cuts into each other. So this exercise will demonstrate a lot of techniques that's useful for design. First, how to use a mesh, how to subdivide mesh, and then how to use how to implement an algorithm to make the geometry avoid itself as it's expanded. Okay, and the geometry that you get in the final is like the result that you get over this like long and interesting process. This is not something that you can model directly with like mouse click and keyboard. You need some sort of logic, a bottom-up logic, and you start with something simple, and then you add in geometry, and those self-avoidance mechanism will force the geometry to take this kind of shape. And by varying the parameters and change a little bit of the conditional setting, you can get like different kind of geometry. So you can go from something that look more like a brain into something that look more like flowers. In this case, probably like carnation flowers. I'm not sure if that's the right name for this flower. All right, so that is like day 2, and probably it's gonna spill over to day 3 a little bit. Now on the day 3, we're gonna focus on the more advanced aspect of both programming and both of logic. So computational complexity. So computational complexity is this is a pre-introduction to the idea of how, when you write certain kind of logic in code, some of them will run very fast and some of them run obviously very slow. So this will kind of help you understand the relationship between, the number of points or the number of inputs in your data and the time it takes overall. So if I have a system of 10 points and it takes me 1 minute to complete, if I double the input, I run it like for 20 points and you expect it to take twice as much, right? Or sometimes actually take 4 times as much. So those kind of thing is, when you deal with like complex system, those kind of complexity is important to keep in mind. And after you kind of understand the computational complexity, we can talk about spatial data structure, which is a way to speed up a lot of logic. So in the mesh growth logic, the self-avoidance collision require that for every point, you have to cross-check this point with other one to see that if they are too close. So if you have 1,000 points, you have to cross-check with the other 99,900. And you see, then how many collisions do you have? It's like 1 million, I believe. So it's a very intensive and slow process. So we can speed that process up using spatial data structure, and namely the R-tree. Now this is a bit quite abstract. Now we're going to talk more about it about this thing on day 3. And then we're going to learn how to use external libraries in Grasshopper. So by external library, so if you use Grasshopper, of course, you use all of the built-in components. When you use, and then when you use either Python or C#, you're gonna implement some extra logic. Now, what if there is another like powerful programming library out there? Let's say like Kangaroo or Weaverbird, and you want to access those extra plugin, not from the Visual Grasshopper components, but from C# code or from RM Python code. Okay, this will show you how to do that. So in this one, we're gonna, so in day 2, we're gonna do an example where we grow a mesh, right? And then I will show you how that we can package that little code as both a Grasshopper plugin, so you can use it from the visual programming. So you can share it with your friend who doesn't know how to use code, okay? And he can like grow a little mesh system for fun. But if for some reason your friend want to access that growth system using C# code or Python, he can also he will be also able to do that. Okay, so and that was for those of you who like use Python. This will show you the relationship or the interaction between RM Python and a C# library. So .NET is a general term where C# language is a part of the .NET family. So any code that you can, any program that you write in the C# language that is comply to the .NET framework or the .NET standard, those code can be accessed from the RM Python languages as well. So you can write a very efficient and complicated plugin in C#, and then you share to your friend, and your friend can use RM Python to access your library. So your friend, maybe just an RM Python user, and he doesn't know C#. In fact, like in this community, like there's more Python user than C#. That's like for sure. So, so this ability to interact between the two different languages is a really nice thing to have. Anyway, all right. So let's carry on. So why? So I haven't told you why C# is beneficial to learn. So C# is a pretty mature language, and it's very well documented. It was, Microsoft was the one who invented this, and they now pushing C# as the dominant programming language for user interface and API programming. It also has a very good community. So if you have general question and you Google it, chance that you will get the question on some online forum right away. Now it is a .NET language, so this is a bit abstract to explain now. But so the .NET language is a kind of is an environment where many software runs in, and C# is one of the language that is used to write a program that run in this kind of environment. And not just Grasshopper is comply to the .NET standard. Many other software, when you write plugin for it, you're going to use the .NET kind of language or framework. So if you want to write plugin for, let's say, another software like Revit, for example, knowing C# will also allow you to do that. Okay. The Rhino Common Library is based on .NET, so the Rhino Common Library is again the library, the program library where we're gonna use C# to access the features of the core Rhino geometry engine. Okay, this one is a bit hard to explain for now, but for those of you and this only makes sense to those of you who already know Python. Okay, so in the next few slides, I'm gonna make a lot of reference and comparison to Python. Now, for those of you who never programmed Python before, you don't have to worry about like this comparison. Okay. And of course, it's much faster than RM Python, especially in Grasshopper. So if you want to do some intensive process, learning C# is like very beneficial. Okay, and to motivate you to learn C#, especially if you already know Python, let me show you some kind of benchmarks that I prepare. So I'm going to show you some speed benchmark between just pure Grasshopper logic, and then the same logic implemented in Python language, and some in VB. VB is another language that is in the .NET standard. It used to be very popular, but now C# is kind of taking the place. And then the final version is going to be implemented in C#, and then we can compare the speed. So okay, for those of you who already know like some programming or some, especially Python, for example. Okay, so here this is a very simple code that basically a very big for loop. Okay, if you don't know what a for loop is because you have never programmed before, don't worry. This is just a simple code that adds the number 1 to this variable a for n times, and n is just a very large number. 10 million. So okay, so this is just a loop that runs itself like 10 million times. Okay, and now let me recompute everything. So let everything runs again. You're gonna see my canvas pause a little bit because it takes quite a bit of time. Okay, and now this is the time that each component takes. So Python takes almost 6 seconds to finish the loop. Okay. Both C# and VB. C# and VB are, have almost always have very similar performance. Okay, so this guy, it takes only 26 milliseconds. Okay, so this is like a speed of factors of like what 200 times, if I'm not mistaken. So that's quite a lot of speed up. Let me run this again just to make sure that everything is fair. Okay, so the difference between this one, so here I have VBScript. VBScript is the version where you type the VBScript code directly in the VBScript component inside Grasshopper. This one is a plugin version where we write the code in Visual Studio and then we compile it and package it as a plugin and we install it. So this one is a plugin component. So in fact, it's actually appear here. So this component came from this one. Of course, I didn't have an icon for this one, so it looks kind of weird. All right. Same with C#. Now, if you run the same benchmark on, I believe, on Rhino 5, you're going to see a difference where the plugin version runs significantly faster than the script version. But I think in Rhino 6, there has been some like engineering work going on. So the script version now runs like I think much faster than before. But I'm not. I have to double check about that. When I compiled this plugin version, I did it for Rhino 5. Now I run it in Rhino 6. That's why it might not be fully compatible. And I remember it should take only 2 seconds here, not 26, or 2 milliseconds here, not 26. Okay, let's look at another benchmark. So this benchmark, we're gonna generate actual Rhino geometry. So just a lot of points. Okay, let me recompute. Okay, so let me look at the Python code. This is just like a for loop that generates a lot of points, okay, and then we just measure the time to see how long does it take to execute. Again, Python is super slow. This is the Python that used RhinoScript syntax library to generate a point. And the second one is also Python, but it's used the Rhino common. And for the ATEC student who took my seminar, I always tell you that Rhino common is much faster than RhinoScript syntax. Now here's like a benchmark where you can see how much it is faster. But even if you use, so even if going from here to here is already a speed of factor of, let's say, 4, if you look at the VBScript version and the C# version, it takes almost no time. It's less than 1 millisecond. This is how fast and how much more efficient your code can run if you do it everything in C#. And if you work out the math, this is a speed of factor of 3 times 120. Okay. The next one is also a geometry example. I think I have to. Okay, this one we're gonna make a little wave simulator. Okay, so each time this component runs, it will draw a little kind of circular wave visualizations. And if I run this again by either do the recompute or pressing F5 button, it will force the component to execute again. Or I can also hook up a timer to it to force it to recompute. Then it will move the wave a tiny bit forward. You see? Now let me make this very large. Okay, so that's the Python versions. So if I have a grid of 200 by 200 points, and if you hold down F5 to make it a recompute, this is the speed you get. Now, frankly, I'm surprised that it actually runs quite fast. This is because last year when I did this benchmark in Rhino 5, it ran much slower, but in Rhino 6, the engineers at McNeil has they have optimized Python a lot, so it runs significantly faster than Rhino 5. That is why I keep recommending you to use Rhino 6 if possible. Okay. So that is the Python version. Let's look at the C# script version. Okay. Okay. I'm surprised to see that it's actually not run much faster. So the Python now runs much more efficient than Rhino 5. Actually, I'm curious. Let me fire up Rhino 5 to see. Since I upgraded to Rhino 6, I've never run this benchmark again. But it might not be correct because if we install Rhino 6, the Python engine might have been overridden. So it still used the Rhino 6 version anyway. Oops. it's kind of freeze. So one component kind of run really slow in the background for some reason. Okay, never mind. I don't think we can test it. All right, let me try to see Subscript version. Okay, between the C# version and the Python, you can see like C# runs slightly faster, but it's actually the difference is not as dramatic as like as it used to be back in Rhino 5. So Python Rhino 6 has improved a lot for sure. Okay, so those are the benchmark. Now let's get a little bit between the different types of languages. It's just a simplified version. So generally, when you do a program languages, the languages itself can be classified into two types: either interpreted language or compiled languages. So Python is an interpreted language, while C# is kind of semi-compiled. So let me explain to you what it means. So traditionally, when you write a piece of code, which basically just a piece of text file, right? So for languages like C++, Pascal, I mean the classic, the dinosaurs of the language of the programming languages. When you write a piece of code, which is basically text essentially, before you run that code, you have to have this special software called a compiler. It will take that text file, the code file, and translate it to basically a stream of 0 and 1 bits that your Intel chips can execute right away. And whenever you modify the program, modify the code, you need to recompile or rebuild that compiled version of the code. Okay, so you have the source code, you run it through the compiler, and you get the machine code, which is just a bunch of 0 and 1, and then you distribute the 0 and 1 to your customer. So your customer will never know what is the original source code or logic of the software. What your customer have is just a bunch of 0 and 1. Okay, but the 0 and 1, it runs really fast because it's already in something that in the form that your Intel chips can understand and execute right away. So it's really fast. So most real software, like commercial software, usually is written, or is the core engine part of the software is written in this kind of languages. The core engine part of Rhino, for example, was written in C++, definitely. So all of the nerves and all of the curve intersection, the actual math, that finding intersection between the curve that compute the curvature or whatever, those codes were pure C++. Now the interpreted language is on the other end, where you have a source code file, but you don't have to translate it to 0 and 1 before you can run it. In fact, instead of a compiler, we have a special software called an interpreter. In this case, the Python interpreter. Now, the Python interpreter is a piece of software. It doesn't have interface. The software is, I call it software, but it doesn't have any user interface. Or it's a special software that the software will take in the source code file, which is like the Python file that you write. It looks at the file line by line, and they try to understand each line and translate it to the instruction, to the machine instruction on the fly. So it does not do everything in advance and just run the 0 and 1 version. It's try to run on the fly. Okay. So it translates to machine instruction, and machine instruction actually it will go down to many levels, and eventually everything will become 0 and 1 anyway. But now the advantage of this is that you don't have to compile it. But whenever you change the source code, you don't have to recompile it. So it's very flexible, but it's slow because everything has to be translated to something that the machine can understand on the fly, right? So when you write a simple line like if a equal to 2, do something, those are like text file, right? The software have to go and analyze each of the text and try to execute it. Here, all of the analysis and understand of the code has been done in advance. And the version that's run is already like a stream of 0 and 1, so it runs very fast, for example. And in between these two streams, you have a semi-compiled languages, in this case, C#, Visual Basic, also Java, where the source code is half compiled, so it's not fully compiled to 0 and 1, but it's compiled to another low-level language. If you look at the So it's compiled to something called an intermediate code. Now, if you open the intermediate code, it's not 0 and 1. It's still, human can still understand it, but it's much less easy to understand compared to the original source code, okay? Now, you will almost never have to look at the intermediate code anyway, so don't worry about that. But so anyway, the intermediate code, even though it's not 0 and 1, it's already structured in a way that it can be translated to the actual machine instruction very quickly, okay? So at first you write the source code in C#, you compile it into intermediate code. So this is what your basically your Grasshopper plugin gonna look like, okay? And you're gonna distribute the Grasshopper plugin, which is already compiled to intermediate code, to your friends and your customers. And then whenever that plugin runs, there is a special compiler called a just-in-time compiler. It will take this like kind of intermediate code and can very efficiently translate it to something that the machine can execute for real, okay? So it kind of offers the advantage of kind of both worlds. So so now let's jump into the actual programming a little bit. So now please raise your hand if you don't know what a variable is. You know, a variable is in programming is. Okay, so you should know. I'm sure you know the basics. Okay, that's good. So in Python, so in programming, you know, we declare or define variable to store data, and this data could be manipulated. Okay, no, the variable is actually, you know, a physical being that store data inside your memory. Okay, now in Python, you declare a variable by just like specify the variable name and then put a value inside that variable, and the value can be a number or a text. That's how you do it in Python. Now in C#, the equivalence of those 4 lines of code in C# would be as follows. So if you want to declare an integer, you say the name, but before the name, you have to declare the type, the data type that the variable is supposed to store. So I want to make a variable A that store integer number. So in C# I'll say int, which is short for integer, and int is a special keyword that the language will understand in like a special way. That's why it will be highlighted. It should be green, but maybe if you look at the projector, maybe it's not that green. And this is the variable name, and then this is a statement, okay? And you end a statement with a semicolon. In Python, you don't have a semicolon, but in C# every statement ends with a semicolon, okay? So here you declare an existence of a variable, and then you assign the value to it, okay? So the first line just declare that I want to create a variable that store integer, and then the second line I throw an actual value into that variable. Now you can do the declaration and the initial value assignment in one line. So if you want to, this is another variable. Now this time we store a decimal number, and in C# a decimal number is called a double, okay? So integer is store for integer, but if you want to store in decimal number, you have to say double. Okay, so we declare a variable b of type double, and rather than doing in 2 separate lines, I can like declare and assign a value right away, and I end with a semicolon. Okay, and here is for text. So the data type for text is string, as you know, and the value of any piece of data of type string has to be enclosed essentially in the curly bracket. All right, and here we go back in and take the variable b that we have declared and defined early on and change the value. Okay, so here we don't redefine the value, we don't redeclare b because b has already come into existence at this line. Here we just take b and put a new value into it. And because we don't redeclare b, that's why we don't say the keyword double. Okay, so you only need to specify the keyword that, you know, describe the type of the variable at the first time it comes into existence. Okay, afterwards you just retrieve it and use the value or change the value to something new. Okay, and now this kind of data type in Python we call it implicit typing, and the other one where you have to explicitly specify the type whenever you want to declare a variable is called explicit typing. Both have disadvantage and both have advantage and disadvantage, as you will see in a second. In the last line, yeah, that's my mistake. If you run that line of code, you will get an error message. So there should be a semicolon. You're totally right. I am. Okay. So another feature of Python is that the data type of a variable can change. So you can create a variable that first store a number, and then at some points later, you can store a piece of data that has a different type. So in this case, I store a type string. Okay. Now this is something that you cannot do in C# and many other languages. So if you declare a variable a that stores integer, then it can only store integer and nothing else. So if you try to redeclare a to be a string, you get an error message. Okay, so an error message say that a variable of name a has already been defined. Okay, so it's not hard to see that both have advantage and disadvantage. You know, this seems to be more flexible. This seems to be more rigid, but it also prevents a lot of potential mistakes. Okay, especially when you have a really long program. Okay. So this one called dynamic typing. Dynamic means that the type can change. This one is static, which means that once you declare what types it is, it can no longer change. If you want to change, you have to create a brand new variable with a different name. Okay. Now here is an advantage of static typing, of explicit typing. Okay. So in Python, let's say you declare a variable called my variable and you store a number to it. Okay, and then at some point later in the code, you want to change the value to something else. Now, but you accidentally mistype the name of the variable. Okay, now what Python will behave in this case is that Python will think that the programmer just want to declare a new variable with different values. Okay, but that is not what you want, right? So Python doesn't understand that you make a mistake. It just run the code. And later on, when you try to use my variable again, and you expect this value to be this one, but actually the value stay the same, and then your code doesn't run as you expected. And at that time, you have an error, you have a problem in your code, but it's difficult to kind of trace back to the original place where the problem occurred, right? If your program is really long, and you make a typo here, the problem will only manifest itself into a real problem somewhere down here. And if you look at the code, it's kind of difficult to, locate where the error is. Okay, so now in the C# language or explicitly typed languages also C++ or JavaScript or processing for that matter, whenever you declare a new variable, you have to say the type. Okay, so my variable of type double, you put in a value, and then later at some point when you change the value the value of variable, but you accidentally mistype the name. Then even before you run the code, okay, when you click the run button, the compiler will say, hey, this variable has never been declared before. So it will point to this line and say there's an error in this line. So you can fix it right away even before the code runs for real. Okay, but in Python, it just happily run. And then the problem will manifest itself usually at a later point. And by the time it manifests itself, it's kind of difficult for you to kind of guess back where it came from in the first place. All right. So this is just one example where, to show the disadvantage and advantage of the programming languages. When you have a short piece of code, Python offers more flexibility. But when you have a large project, this kind of mistake can occur quite frequently. So you need a more safe and more. It can be rigid, but it's more safe way to program and prevent potential mistakes. So in that case, explicit typing is more appropriate for really complex piece of logic. Okay. All right. So far we talk about number and text. We haven't talked about any geometry. We even have touched on Grasshopper. Okay. So one person asked from the online session, what's the difference between C# and Java? I'm sure that some of you also want to know what's the difference between C# and Java, because if you have programmed in Java before, you're going to see that the syntax or the grammar or the rules looks identical. In fact, it is very similar. I would say 95% similar. Historically, Java was super popular. It was created by this company called Sun, Stanford University Network, I believe. Microsoft used Java a lot, and then later on they modified Java to fit into their Windows platform, and it kind of upset Sun system a little bit because they kind of not they're not happy seeing their old programming language being modified so much by Microsoft. So Microsoft decided, okay, we don't use Java anymore. We just like invent our own language called C#. But it looks so much like Java because the syntax is so popular at that time. But Java itself is also based on kind of C++. So all of these language, usually the syntax is usually referred to as the C style syntax. Okay. Now, most of the programming language that you learn these days kind of look more or less the same, unless you do some scientific programming like MATLAB. Then the language feels extremely different. But most of the programming language that you are going to do is going to be like have some if statement. You declare a variable, and you have a for loop and a while. So it's just like speaking American English or Australian English or British English. They still essentially English, but with like different dialect and different like subtle difference in meaning, especially when it comes to the humors, for example. Okay, so let's jump into actual some a real life example here. So we're gonna make a very simple C# script that take in two numbers from the Grasshopper canvas, add it up, and return the result. Okay, this is like a very silly, trivial example, but it shows you how it works. So, empty canvas. Okay, let's create a C# script. Okay, we're back online again. So the variable name. So when we write code inside C#, we can refer to this input part using the same names. Okay, so this will be mapped to a C# variable of the same name. All right. So that is the name, but again, variable when in C#, it's not only the name that matters, but also the type. Okay, so X, let's right click on that and go to type hint, and we will set the type to a double. Okay, and double means a decimal number. Yes. Yeah, but it's back online now. It got disrupted for like 5 seconds. Is it back now? Okay. All right. So let me explain again because there seemed to be a 5 second, like a 10-second disruption on the live stream. So so we have a C# component with two variables. The variable have the name X and Y. You can change the name by right click on the input and change the first line. And the name of the input will be the same name of the C# variable inside the script. Okay, but in C# the name is not the only thing that matters, but also the type hint. So because we want this component to take in two numbers, two decimal numbers, and add them up, so we want to change the type of the input to double. Okay, we're going to do the same for this input. Right click, type hint, and change it to double. Okay, we only specify the type for the input, but we don't have to specify for the output because the C# component can automatically guess the type of the output for us. Okay, so if we output a curve, the C# component will automatically know that it's a curve anyway. All right, now let's plug in some data. So I will make a little slider. Okay, now we can open the code editor by double click on the C# component. Okay, so this will open the code editor. We can type in the code, and if you have never opened a C# script editor before, please don't be traumatized by the amount of code that already exists. Okay, I mean, if you use Python before, you open and like it's a completely like blank piece of like code file. Here, there's a lot of code. Okay, so don't worry. You don't have to understand any of this right now. Okay. This is where we type the code. This little white space here. This is where we type the code. The other part has been grayed out. Okay, which means that you cannot even edit or change anything. Okay, you can select it, but if you try to type, you cannot do anything. So only the white bit is where you can change the code. Okay, now just before the place where we type the code, you have some with template code here, but it doesn't matter. This is what you should care about. So this is a double X. So this is like the variable that match the input type double x double y and output colon a. Now ref object, you don't have to worry about what it means, okay? So just know that the output is a, okay? All right. So so x is a number, so I can just add it to y, obviously, and this will give me a number, and I will just assign that number to the output port colon a, and I end the statement with the semicolon. Okay, as simple as that. All right, and if we have a little panel, we can see the output, which is 2. Okay, that's good. And whenever we change the input, obviously the script will automatically be executed, and we will get the live update of the sum. Okay, what if you want to have more output or more input, similar to the Python component? If you have used the Python before, you just zoom in, okay, and then you can add more input or output. So let's add one extra input, z of type double, okay, and an extra output colon b. Okay, and then I just hook up some data to z, okay, and now my code is just adding one simple line just to see how we have to output. So this one is gonna be x plus y plus z, for example. All right, just a word of warning, actually a very important warning. I'm a bit disappointed they haven't fixed it in Rhino 6. But when you open the code editor, you type in some code. If you press the play button, the code will execute. If you click the OK, then it will close the code editor window and execute, okay? Now here's where you can like have some really annoying problem. If you open the code editor, and then you double click again, it will open another version of code editor. And which one you close first, we have the final say. Okay, so this one, if you say a plus y plus z plus 2, and you do this, okay, it will take that version. But if you then close this one later, so which one you close the final, we have the final say in the code. So it can be annoying. Okay. And worse, by default, this code editor will automatically minimize. So this toggle here, string script editor, is on by default, which means that whenever you click outside the code editor, it will shrink. Okay, this makes you think that it will go away, and then you have the tendency to open another version, and then you write something. Okay, you click OK, and then some point later you publish up, and you see that new line. That new line that you just add is not there. Okay, so be careful with that. So I actually normally I just turn. Oh, something weird going on. Normally, I just turn off this option so the code editor is never shrink. Okay, so I don't have to accidentally forget about it. Okay. Okay. All right, let's create some actual geometry now. So we know the data type integer, double, and string. We haven't actually write any code that using text yet, but you saw like some just code example online. Now let's do actual geometry data type. Now the integer, the double, and the string, those are the data type that came with the C# language by default. So they are kind of independent of Grasshopper. You know, if you use C# language outside of Grasshopper, you have access to the data type. Now we're gonna touch on a data type that is specific to the Rhino common library. And the reason why C# can understand this new data type is because the C# script editor that you type in the C# script component already kind of see the Rhino common library. Then the Rhino common library is actually just a file sitting on your C drive, C/program file/Rhino, okay? And the C# code editors already see that file, and this data type is defined within that file. So that's why when you write code in C# script component, you already have access to all of the data types that's were defined there. Okay, probably I should close the curtain a little bit. Okay, so this syntax is gonna look very similar to Java again, very similar to Java or processing. So we gonna declare a variable of capital A, okay, a big A. The type is point3d. So point3d is a C# data type defined by the Rhino common library that you should store, unsurprisingly, a point in 3D space. Okay, now the D here doesn't stand for dimension. Actually, D here stands for double, because this point is represented by the XYZ coordinate, which is 3 decimal number or 3 double. So the D stands for double, not like 3D in the word 3 dimension in the English language. Okay. All right, so this is declare an assistant of a variable. Now on the right side, this is where we actually create a value of the point so that we can start in this variable called A. Now we're gonna, whenever we want to create a value from scratch, okay, we have to use the keyword new. Okay, the exceptions are the basic data type. So integer, double, and string are basic data type, and you don't use the new keyword. When you want to create a double, just type in 0 point something. Okay, but for the non-basic data type that's defined by a custom library like Rhino common, you always have to use the new keyword. Okay, so new point3d. Okay, so point3d is a special function or a special command. Okay, if you don't know what a function is here, just think of it as a command. Now the command always has the same name as the data type. Okay, and the command will take in a bunch of parameters, optionally take in a bunch of parameters inside the brackets. Okay, so in this case, we new point3d, nothing inside the bracket. This will give us a point whose coordinates are 0, 0, 0. So that's a default value if you don't supply anything, and we end the statement with a semicolon. Now for those of you who using Python, you already seen this syntax, right? Except that you don't use the new keyword in Python. That's the only difference. Okay, and you don't have a semicolon. But and again, if you never used Python before, just ignore what I say. All right. So at this point we have a point A. Okay. Now in the next slide we create another variable. This time we call it B, and this time we construct a new value. This time we supply some coordinates 0, 1, 2. Now how do I know this syntax? How do I know that these special commands accept 3 numbers and treat it as the XYZ coordinate? Well, that's because of the documentation. Well, first because of intuition. When you look at that, it's kind of obvious that it has to be XYZ coordinate, right? But in some less obvious case, you have to look at the documentation of the programming languages to understand what each command is. Okay. All right, and then finally, another way to construct a point is, to construct a point is to copy the data from somewhere else. So here, the equal, rather than construct a new, a brand new piece of value using the special constructor command. So the constructor is a special command that always has the same name, the exact same name and the exact same capital casing as the type name itself. Okay, so instead of using the constructor command, we can just simply take a value here and copy. So the equal here act as a copy operator, where the contents of point B will be copied into a separate independent copy, which will be stored in C. Okay, and what I mean by an independent separate copy will be clarified later on. All right. Okay, and then we can send this to the output. Okay, so this is just basic C#, but when you do it, the C# component, if you want to see the actual point, you have to send it to the output port. Okay, otherwise you won't see anything on the Grasshopper canvas. Okay, so let's open this code editor. We're gonna declare a variable of type point3d. We call this myPoint. Okay, and we're gonna construct a new value for the point. So new point 3D, and put in the coordinate 1.0, 2.0, and let's say 3.0. Okay. And this line will create a point, except that when you run the code, you don't see anything on the screen because this point is created and stored internally inside the C Subscript. You have to output it in order to use it in the Grasshopper canvas and also to see it on the screen, right? So you have to, let's go back to the code editor and add one extra line, and we say A equal to my point. Okay. And you should see a point as the coordinates that you desire. Okay. Instead of hard code in the coordinates 1 and 2 and 3, you can take the coordinate from x, y, and z, provided that if x, y, and z are double, okay? So you can try that if you want, but let me point out important points. So for those of you who learn with me in the Python seminar, you already know about the variable naming conventions, but I think it's important to repeat again. So same thing applies in C#. Variable name use mixed casing or camel casing. So camel as in the name of the animal actually. So camel casing means that the variable names always start with lowercase, but every time you have a new word, you use the uppercase, okay? But the initial one always lowercase. So that's why I say my point with lowercase m and uppercase p, okay? Now the type name on the other hand always start with uppercase, except the basic data type like double, integer, or string. Those are like the basic one, and they start with lowercase, but almost all the other data type like point 3D, and later on you will see like curve, vector 3D, or mesh, the name always start with uppercase. Okay. And by that convention, I tend to name my input port using lowercase as well. All right, let's go on to the if statement. This is how you do if statement in Python. I'm sure you can understand the logic of if statement, right? Even though you haven't like programmed before, but I think you all understand this, right? Okay, raise your hand if you don't like know what an if statement is. Okay, good. All right, so this is how you do it in Python. So if you have two input code A and B and you compare it, and then in Python, the Python script component support the print command, which basically output a special piece of text in the output port, okay? The output port is used for like debugging, for helpers to understand the problem more than for the real output. Now the equivalence in C# gonna be if the if keyword, the conditions has to be always be in bracket, okay? Now the body has to be enclosed in curly bracket. Now in Python, the body doesn't have to be enclosed in bracket because Python used the semicolon together with the indentation to know that these two statements belongs to the if statement. But C# does not rely on indentation. So the indentation here is just to make it easy for us human to read. If you don't have indentation here, C# still runs. So C# purely relies on the semicolon to know where the statement ends, and the curly bracket to group a block of code together into like one being. All right, and then this is the else statement. So the print command, the C# script component also supply a special print command, except that you have to do capital P. Okay, so in Python, this print command is somehow spelled with lowercase, but in C# it's uppercase. Okay, so the message will be printed out in the output port. Okay, so if I you don't have to follow this because I think it's quite trivial, but let me just copy and paste it in here, A and B. Let's change this to double and Y to double. And let's change this to A and this to B. Okay, so if A is 1 and B is 2. Okay, I get a message being printed out, and all of the one that you send to the print command will appear here. Okay, so that should be very straightforward to you. Okay, let's carry on. Okay, so the if statement. Now we come to more exciting part, the for loop. Okay, raise your hand if you don't know what a for loop is. Oh, everybody have done for loop before, even the non-ITech student. Oh, okay, that's great. So I don't have to explain the basic thing again because it's gonna take. You don't know? Okay, that's fine. I will explain. Okay, so for some, if you have a piece of code, like let's say 5 lines of code that you want to execute over and over again for, let's say 5 times, rather than copy and paste it 5 times, you can put it inside a for loop. Now the for loop say that so for I in range, this is the Python version, but basically I is just a special counter. I will take the value of 0 at first and execute this code. So the first time this command run, it will print I, and the first time this run, I will become 0. And then it's execute again, but the second time it's execute, I will take a value in 1, because so this range 0 and 5, it generates like 0, 1, 2, 3, and 4, and each time it runs, it's the same code, but with the different value of I. Okay. Now this the body of the for loop here is like very simple. It has only one statement, but you can do some math here rather than just print. You can, let's say, print I plus 2, or you can draw a coordinate, a point at point I, for example. Okay. Now this is how you do it in CSharp. Just like a little bit more verbose. Okay. So for, and then you declare a special variable called I. Okay. Now I is an integer. It starts with 0, and this for loop. So the body of the for loop will run as long as I is less than 5, okay? And each time the body finish, it will execute this command with basically I plus plus, which means that I increase by 1 every time it runs. So the first time, so let's say that you have a program, the execution do line by line, and eventually it reaches the for loop. When it reaches the for loop, it will create I equal to 0, execute this line, and this line basically just print the value of I. Okay, toString is basically, so I is a number, so the CSharp provided toString command with it's a command, that's why it has this pair bracket here. So the commands, when you execute a command, you always have brackets, and the bracket is where you supply the parameters. This command doesn't have any parameters, that's why the bracket is like doesn't contain anything inside. It's an empty bracket, but you still have to write the empty bracket. Okay, so the first time it's run, it's print I equal to 0, and then it go back to the for loop and check if the condition has been met. It hasn't, so it's go in and print I equal to 2, and then it's increase I by 1, and then it check if this condition has been met. So if you execute this code, let me quickly copy and paste. Okay, this code does not rely on any input at all. So if I copy and paste, it will print 0, 1, 2, 3, and 4. Okay. Yes. Right here.
You don't have to declare the variables before, right? Before the
The variable I declared inside here, int I.
So you don't have like a specific place for, you don't have to declare everything before.
You can as well, except that normally for the for loop we want to declare the inside, which means that this I will only be available to use inside the body of the for loop. If you declare it outside, this is what happens. So int I, okay, and here you don't redeclare, you just assign a value. This time, even when the for loop has finished, the value of I is still accessible. So if you print out I here, I will be the last one, which is 4. Because by the time this loop finished, I will be 4. Okay, if you print out I here, it will be 4. But this is not something that we want. I mean, there's no reason we want to access I after the loop finish. We want to create a variable I so that it can only be used in the for loop body. So that's why we declare it here, so we don't accidentally use it outside. Yes? I plus plus is just like Python, increase by 1, increase the value of I by 1. You can also, in Python, this is, I think you use this in Python, right? Okay. if you, this is just another notation, but have the exact same functions. Yeah, this is the long version. So you increase the value of I and you reassign to itself. Okay, but of course, because this operation is so common that most programming languages like support this special shortcut. Okay, and if you of course you can jump by 2 every time. If you jump by 2, then you will see 0, 2, 4, 0, 2, 4, and then that's it. Okay. You can do backward. Let me move the integer I here because that's normally how it should be. All right. That is one loop, right? I'm gonna print an empty line. Okay, so I should see an empty line coming out here before I move on to the next for loop. So there should be an empty line here. Okay, just so that we separate the two parts easily. All right, I copy this one, but this time I change the loop logic slightly in slightly different manner. This time, let's say I start from 10. I run this thing as long as I is still positive. Each time I run, I decrease I by 3. Okay, so I equal to itself divided by 3. Okay, you can write out the long form if you want. So I minus 3. This is the long version of that. And this time you should see the print out. So you should see the normal print out, an empty line, and then followed by 10, 7, 4, 1, and that's it. So 10, 7, 4, 1. Okay, and 1 is the last one that is greater than 0. Okay. Now it's important to see that these are two different versions of I. So because I use the keyword integer here, so this int I is a variable that is local or only available to this part of the code. This one is a brand new variable. It just happens to have the same name, but CSharp we treat it as an entirely different variable. Okay. So this I has nothing to do with I. They just happen to be called the same name. Now, the next thing I just want to demonstrate, don't do this at home because it will crash your computer. So you see, this is important for this loop to terminate because without this part, I will never, reach this condition and the loop will never finish, which means that your computer will run and you will have to do alternate control down to, stop Grasshopper together. So for example, if I make a mistake and I say, I plus, which means that I will get larger and larger. So this condition will never be met, right? So this thing will run forever, and at that point you have to do alternate control down to to quit Grasshopper and or to quit Rhino entirely and start it again. So okay, I'm not even going to run it because I don't want to restart my Rhino, and don't do it at home. And also it's very common to rather than say I plus plus or I plus 1 here. There will be a case because of copy and paste. If you copy and paste somewhere else, you have to change the variable name. But sometimes you don't change it fully, and this thing stay as like k. This will also cause problem because this condition is never met, and you will crash and burn. Anyway, so let's. Okay, let's move on to the next concept. Now, we cannot really draw any geometry here just yet. We just do number and print our message here. Before we use the for loop to automatically draw, let's say, a list of number whose coordinates is going from 0, 1, 2, 3, and 4, we need to learn about list in C# a little bit. So, the console? The console, the main Rhino command line. Yes. Instead of want to print out here, you can send a print message here. So that's one is Rhino app dot write line bracket and give it a little text. Okay. So if you have a text in the So this one will print hello world 4 times because this loop will run 4 times, right? But every time it's run, we just print out we just display the message hello world in the console right here. This code doesn't even care about the value of I, so the I just acts as the counter for the for loop to eventually terminate. But you know the logic here doesn't even care about the actual value of I. So you're going to see hello world being printed out 3 times here, 4 times here. Okay. There is an advantage of using Rhino app write line rather than the print. Okay, let me show you. So let me revert to the original version. So print I dot to string. Okay, this one will only display if there's no error in the script. If the script executes fully, you will see it being displayed. But if there is a mistake, so after you print it, and if you like have a very silly line of code that causes an error, but we don't have any logic that causes a problem now.
Long.
Yeah.
In my case, it's saying that the name I is not accessing the current context, like in the second in the.
Okay, make sure you have no semicolon here. Make sure you don't have a semicolon here. Okay, that's a pretty common mistake. Because if you have a semicolon here, it will interpret this as a for loop. If you put a semicolon here, it will in C# we treat this as a for loop with an empty followed by an empty bracket, which means a for loop that doesn't do anything. And this one is treated as separately, which means that look at I and say, yeah, I don't know what you mean by I. Okay, because I is here, and this is like in a different block of code, so that's why it will complain. Okay.
Does not contain a definition for string and no extension with string except.
Okay, to string, make sure that you spell with capital T and capital S. Command always uppercase. All right. Let's carry on. Let's look at list. List and for loops like goes hand in hand together. So far each variable that we learn only contain one piece of data, right? What if we have one variable that contains a list of data for convenience? Okay. In Python, again, if you have never done Python before, you can ignore this part. But in Python, this is how you declare a variable that stores a list of objects, right? And each object here, or each item in a list, turn out to be just a number. So you list out the items, separate by by comma with a square bracket, and then you can add new item to the end of the list. Then you can retrieve an item using the square bracket. Okay. Now this is the equivalent in C#. Okay, so C# is slightly more convoluted or more complex because in C# again, every variable, whenever it first comes to a system, you have to specify the type. Okay, so I want to create a variable again by naming convention. It's uppercase, it's camel casing. So the first word is lowercase, but then it's uppercase. Every time you start a new word. This is a convention but not a rule, which means that if you don't follow the convention, the code still runs fine, but it would just make it harder for yourself or for your fellow friends to understand because if you don't follow the conventions. Okay, so we create a variable. Now this time the type of variable is list. Okay, and the list store double. Okay, so in C# a list store all the item in the list must have the same type. Okay, and the type of the item in the list must be declared in advance. Okay, so we're gonna create a list that store double number. Okay, so list and then angular bracket. So this is special C# syntax that specify a list that should store a double number. If you want to store a list of point3D, then of course you say list angular bracket and point3D. Okay, so this is the whole thing is the type. Okay, this is the variable name, and now we're gonna create a new using the new keyword. Okay, so similar to when we create point3D, we're gonna say new list double followed by empty bracket, because this is a command. So a command always followed by round bracket, even if the round bracket does not like contain any parameters. Okay, so at this point we can put a semicolon right here. We can stop right here, and then we have an empty list. But in C#, after you have, when you invoke the list constructor command, you have the chance to open the curly bracket and specify some initial items. Okay, so here I throw in like two initial items, 0.5 and 3.14. Okay, now in the next line, so after this line has finished execution, I move on, the code will move on the next line, and we execute this command with basically my numbers dot add. Okay, so we invoke the numbers, the variable, and we say dot with, and then we can access all of the command. So the add is a command that is available to any variable of type list. Okay, if you try to do add on a number, it doesn't make any sense, because you know the add operators on a number is like you use the plus operator. You don't add by saying the command. So my numbers to add will add this new item to the end of the list. Okay, so after this line finish executing, your list will contain 3 numbers. Okay, and now we added the new numbers. Okay, to retrieve a number in C#, you used also the square brackets. Okay, so this is how I retrieve the 0th item, the first item. Okay, so if you have never done, okay, well actually you use Grasshopper, and you know the list in Grasshopper also start with 0. Okay, so you should not, I think you kind of already used the fact that list, the index start from 0. So you access the 0th item, you convert it to a string to print it, to display it. Okay, so that is how you access, you have a list. Okay, now let's use list and a for loop to create a series or a sequence of point. Okay, so I will have another C# component. Okay, we don't need any input, so I just remove all of the input. Okay. All right. Now, this is a standard way to use a for loop to generate items and put it in a list, and then finally we output that list so that we can have something on a Grasshopper canvas and something to see on screen. Now this time we create a list that store point3D. So list point3D. Okay. And we call this one my points, using the same naming convention, my points. Okay, so list name, this is not a strict convention by the C# programming guideline, but it's kind of many programmers, including me, adopt. So list name usually comes in plural form, so S. Okay, my points, and then we create a new empty list of point3D. List point3D. All right, and if you use Rhino 5, same with Rhino 6, actually you will notice that the autocomplete in this code editor sucks really badly.
No.
Yes.
So first you were saying that you were creating a list.
This part create a variable that only accept data of a type list point3D. Okay, this one has, this thing is just a variable. It has no contents yet.
Yeah.
Now this one we actually create a content, and the content happens to be an empty list for now. Okay, and then we store the content into the variable. Yeah, or we link it to the variable. Okay, now we can access a list because now it's stored in variable, so we can we had a name to refer to it. So my points dot add. Okay, and then we can add let's say a new point. Okay, so Okay, now I can construct a new point right in here. Okay, so if I have a point that's stored in a variable called, let's say my first point, I can type in the variable name here. But here I don't have any point on any variable that's stored upon yet, so I have to construct a new point from scratch using the new keyword, point 3D. I put in some coordinate, and you will notice I have like nest bracket here. Okay. Okay, I copy the same line, I paste it so that I will have another add command. This time I add another point, but with slightly different coordinates. Let's make it a little bit higher, just fine. Okay. All right. If we run this code, we're gonna. So if we run this code and if we add this line, okay. So by the time the code execution with this line, we're gonna have a list called my points that has 2 points at the coordinates above. Now, if you run this code, if we run fine, except that nothing is being output yet into the Grasshopper canvas, so you will not see anything. So we have to output, so A equal to my points. And then you should see 2 points on the screen, hopefully, yeah. Now, of course, you don't want, if you want to do 100 points, you don't want to copy and paste 100 times, right? So that's where we're gonna use the for loop, okay? All right, so let's go back in the code editor and remove these 2 lines, okay? Okay. So we have an empty list now, and now we're gonna use a for loop to populate the items in the list. So for integer I start from 0, I run for, let's say, 100 times, I plus plus, okay, and open curly bracket, okay. So let's create a single point first. So point, and this is called point lowercase. This one has coordinate I, okay. And we're gonna add that point to the list my points, okay. And if you run this, you should see 100 points going in the diagonal. Fred, the video quality online, is it like full HD? Yeah, on YouTube. Is it like 1080p resolution? Yeah. Okay. Now go in just a small subtle point. So here, every time the code runs, every time the body of the loop runs, I create a variable called point, and the next time it will create a brand new variable of the same name, you know, but it will create add, and then, you know, the next time a new variable. Now in this simple example, I don't even need this temporary variable to hold the point. You know, I can just do this part right here. I can cut and paste it right here, and I don't need this temporary variable in this particular simple example. Yes. Yeah, okay, good. Okay. So so when would you want a temporary variable? Just like in the case I had before. So for some reason, if you want to reuse this point to do some further logic right here, okay, for example, point dot distant to or compared to or whatever, then yeah, it makes sense to store the point in a temporary variable. But otherwise, you don't really need this temporary variable. Okay. Now the next point, in the case where the body of the for loop has only one statement, you can remove the curly bracket. Okay. You can only do that if it has only one statement. Okay. However, certain programming guidelines strictly dictates that the curly bracket should always be there, even if there's only one statement, because it makes the code kind of a bit easier to read. But it's more like something of a personal preference. So I tend to remove the curly bracket if I have only one statement. And unlike Python, the line break and the indentation is just purely for readability. So in some case, if the body of the for loop is so short, you can even write it on the same line and it's still fine. You know, for I to 0 to 100, add this to my point. In this case, I have to do a new line, a new point here. Okay, yeah. Of course, it's slightly harder to read if this line is very long, right? So that's why normally you write it in two separate lines. All right, it should be comma, yeah. Okay, raise your hand if you have never write a nested for loop before, a for loop within a for loop. Okay, I totally expect this, so don't worry. I gotta explain next step very carefully. So, as I said, inside the for loop, we can have basically a block of code, right? And the logic of the code inside this block, I mean by block I mean the curly bracket, can be like as complicated as you want. Well, here it's very simple. Now it can be. This is what I'm going to do. Inside the for loop, so each time the for loop run, I call it the I for loop, because each time it's run, the for loop is being tracked by the special variable here, or the special counter here called I. So this is the I for loop. Each time it runs, what if I fire up another for loop? Okay, but this time the for loop has a different counter called J. This time it's run from 0, and let's J less than 20. Okay, J plus plus. Okay, and then curly bracket and close curly bracket. Okay, and you see how I do indentation and curly bracket. Okay. Okay. So every time that I runs, it will initiate a child loop that run J for 20 times, okay? And then I can use the coordinate of I and J to do points, so my points, dot add, new point 3D, I, J, and coordinate, the Z coordinate is going to be 0 in this case. And this one, instead of having a line, you're going to have a 2D grid of points, okay? So for every I, so like a grid of size 100, 100 by 20. Okay, so the idea of nested for loops is like a very common technique. You can nest even like a smaller for loop here, and then you can have like a volume of points instead. Okay, a word of warning. This is very commonly occurred, and it occurred to me like on a weekly basis. So don't be embarrassed if you like run into this yourself. So a lot of time, it's of course it's very common for you, instead of like doing J manually, people tend to copy. People tend to make a copy and then they change the variable name to J, and this one to 20, and they often change the last one to J. And you know what's gonna happen, right? This J will never reach 20. So again, let me say, sometimes you tend to like do copy and paste here, and change this one to J, this one to J, and the last one should also be J. But sometimes you forget to change the last one to J and it stay I, which means that J will never increase. Because J never increase, it will never reach 100, which means that this thing will keep running and running forever, and will never terminate. And you have to do alternate control del to quit your write altogether. So be careful with that. Okay. Okay, if I run this one, I should get a pretty large grid here. Yeah. Okay, so we're gonna building up our kind of arsenal of logic. So we do list, we do for loop, and we create point. All the things we've done so far is like pretty toy example. Nothing really exciting yet. Just like create a point so far. Okay, let's have a slightly different version of the for loop. This is called a for each loop. Okay, so the idea of the for loop is that you have a counter that increase, and then each time it runs you do some logic, and the logic inside the for loop sometimes it doesn't even care about the actual number that's stored in I. Like you saw when I print out a hello world message 4 times. That statement print hello world doesn't really care about the value of I itself, right? Now, what if you have a list? Okay, let's say a list comes from outside of the Grasshopper canvas, or like the list came from the upper part of the code, and you want to visit each item in the list. What you can use a for I loop to do that, and you use I to index into the element of the list. But there is a more natural way that's more sounds like plain English. Okay, so for each. Okay. So this is a loop that visits each element in the list. So points here is of data type. So points is a variable that came before that has data type list of point 30. And this loop will basically visit each item in the list points. Each time it visits an element, it will store that element in a temporary variable called point. And it's stored in a variable so that you can refer to it. If you don't store it in variable, you have no name to call that variable when you write the code. Okay. And then you can use this variable name here. Okay, so let me show you an example. So let's have another CSharp script component. This one will take in a list of points, and for each point it will draw a circle, and then we end up with a list of circles, right? And then we're gonna output those circles. So only one parameters, only one input part. We call this points. Okay. Points is of type point 3D, so the type in is of point 3D. Okay. But it's also is a list input. Okay. So if you right click, you have to choose a list. Okay. So we tell Grasshopper that we expect this to be a variable. So in the code, whenever you type the word points, it will be referred to a CSharp variable of type list of point 3D. Okay. All right, let's give it some points. So I will just supply some actual point here. And we do a few, and I plug it in. All right. Okay, let me show you these two versions. So again, we want for each of the input points, we want to create circles. We store all the circles in a list, and then we output that list. Okay, so we can see it. So let's create a list of an empty list that will store circle. So list circle. Okay, so circle is a data type. Okay, this is the first time you see it, but this is the data type that represent circle. Obviously, this data type also came from the Rhino Common Library. Okay, we will call this circles plural because it's a list. So, and then we assign an empty list of circle to it.
Could you set those multiple points before you present
If yeah, I give it multiple points. Yes.
it?
Yeah, set multiple points. All right. And now we use the for. Now, okay, so points will come in here, right? You see in the first line, now we have an input for points. The type is list point 3D. So which means that whenever you type out the word points here, it will refer to this input port, okay? If you misspell points, obviously, it will say that point does not exist in the current context, okay? But now it does exist because it's the input port that comes from here. Okay, so I know it's annoying, but there's no way to disable it. Tomorrow when we do Visual Studio, you're gonna see how a real code editor is supposed to be like, okay? David Burton himself, I once saw him complain on Grasshopper forum about he used the word atrocious to describe this code editor because apparently he hated this code editor himself because it's autocomplete sucks. Everything sucks actually, not just autocomplete, but also code refactoring. Okay, so points. Okay, so let's do a for each loop. So for each, okay, bracket. Okay, inside the bracket we will say point 3D. So we create a temporary variable of type point 3D. Okay, we call it point singular, and point will sequentially take the value of each item in the list points. Okay. All right, so okay, so let me remind you again. This line, point 3D is the data type. So we declare a variable component of type point 3D. Point 3D is a data type. That's why it's capital. In fact, because this code editor sucks, that's why it's black. But if you write it in Visual Studio, because it's a data type, it will be colored as green. Okay, this part is also green. So data type is usually like being highlighted using a different colors. But this code editor just, you know, provides some very basic highlighting, and it's kind of annoying to work with for now. Anyway, okay, so instead of having a variable called I, and each time I run and I be like an integer, this one we have a point, a variable called point, and each time it runs point, the first time the body the body of the loop is executed, point will contain the first item from the points list. And then the second time it's run, point will represent the second point in the list. Okay, so what we do is that we're gonna use point here that will describe the current point that we are visiting in the list. So we use this to create a new circle. Okay, so this is the command to create a circle. So new, unsurprisingly, circle. So similar to new point 3D, but this time we call new circle. Open bracket. Okay, and a good code editor again will show you this little tooltip to give you a hint of what parameters you can supply to the function or to the command. Except again, this code editor sucks, and in fact in Rhino 6 it sucks even worse. So that whenever I move my mouse to it to switch to click this button, it just damn it. So anyway, I remember what the command is, and so you just follow me. So a circle will take in, unsurprisingly, the center point, which happen to be this guy. Okay, so that is the first input parameters. The second one is a number that specifies the radius, and we're gonna hard code in, let's say 2.0 for now. Okay.
Don't you have to say that,
Yeah. Well, hang on. So this is just create a value of the circle. Okay. Now I have to do something for it. I have to store it in a variable. So let's create a variable called circle, and call it circle with lowercase singular equal to new. Okay. All right. That's the complete statement there. Okay, so good questions. There's no difference in mathematics. In programming, there's huge difference. Integer and decimal number are treated quite differently by most programming languages. In this case, if you type in 2, it will be converted to 2.0 automatically, so it's fine. As a programmer, I want to be explicit because I kind of it's important to remind myself that you are dealing with decimal here. The potential downfall of using integer and assume that the computers will understand it correctly is the most common case when you do division. Let's say that when you write, you don't have to do this one, I just show you an example. So int a equal to 6 divided by, let's say 7 divided by 3, okay? 7 divided by 3, what do you expect in this case? I'm sorry, let's do it by 2 because it's easier. Do you expect 3.5, right? But because you specify this as an integer, it will think that you want an integer answer. So instead of 3.5, it will round down to 3. Okay? But by saying that this is a double and being explicit, it will give you the answer 3.5. Okay? This very commonly occur, and this is the a very common scenario. Is let's say that when you have, let's say, a double cone temperature that stores the current temperature in the room, which is like 35.4 degrees, for example. Okay. And then another double store the maximum temperature that the room can accept, which is, let's say, 100, okay? And you want to work out a ratio to know like how much percentage that you have reached to the maximum. And you normally say the ratio is just 10 divided by max 10, right? And in this case, you should get 0.464. Now, if you store this thing as an integer, this is where the problem comes in. If you do it at integer, and you try to do the ratio, so 36 divided by 100 gonna be 0 point something, right? But it will be rounded out to 0, and then it will be converted to 0.0 because you asked for a double, and then your result is gonna stay 0.0 all the time, and then if you use this ratio to do like further computation downside, it will always like give you 0, and it will lead to a weird problem that is kind of difficult to trace back where the problem is, because that problem usually manifests itself like further down in the program. Okay, so that's why I tend to be explicit all the time and do 2.0. Yes. Yes, so the data type is important. Yeah, so there's two good question that he asked actually. So again, circle is a command and it accepts a certain number of parameters, right? Now the reason why I didn't talk much about this because autocomplete sucks, so I could not show you like the specification. But if you look at the first version, you can see a hint. It say that it take in one variable called radius and the type is double. So if you supply only one number and close the bracket right away, it will give you, unsurprisingly, a circle right at the center because you don't specify a custom center, so it will assume that you want to do it at the center, and it will take in the number as the radius. In this case, if you give it an integer, it will make the best effort to make this work by converting it to double automatically. Now, if you give it something silly, if you new circle and you give it a piece of text called hello world, it will complain. It will say that there is no command circle that take in a string. Which kind of makes sense, right? Because it doesn't make sense, but If you look at the documentation, yeah, then there's no circle command that take in one parameters of type string. Okay. So in fact, the circle command, there's actually 7 different versions, and normally you can browse through them by just like click on this arrow in the tooltip. Except that it's really annoying. And each version will tell you which parameters and the type of the parameters that it takes in. If you supply a list of input that doesn't match the type and it could not make the best effort to find the one that matches, it will complain. And the error message usually say there is no version of circle that take in a string and a nerve surface, for example. Yeah. So yes. Yes. So that is okay. So the help file, there's no like integrated documentation in the code editor. So the best thing you can do is to go online. Now I hope autocomplete will not reveal any of my embarrassing history. So let's see. Okay. Whew. Okay. Random common documentation. Okay. Okay. So if you Google for Rhino Common documentation, you will go to the official documentation of the Rhino Common library. And this thing is an online thing, so it stays up to date. There's also offline versions. Now, it might be a bit difficult to navigate at first because we haven't learned about namespace, so you kind of don't understand why they organize in like this kind of fashion where you Rhino dot something. But let's say that you already browse to the right data type, which is circle. This is actually worse than Google search. So Rhino circle curve class circle prep Rhino geometry. Here circle structure. Okay, so again, the documentation is a bit cryptic, but if you look at here, I keep saying the word constructor function, right? Because the constructor function is, or constructor command, is a special command where you actually create the value from scratch for the first time, okay? The other command acts on already existing value or data, but constructor command is like to create the data in the very first place. So if you look at the specification here, there are 3 versions. So circle, the first version, take in a number. The other one take in an object of type arc, okay? Arc represents an arc in Rhino Common. This version take in a plan and a number, so the plan will specify both the intuitively, I mean you can guess why it's taking a plan because the plan will specify not only the origin of the circle but also the orientation of the circle, right? Together with radius. This is a circle that goes through, okay, this one is a circle that takes in 3 points, so through in the 3 point you can like uniquely define a circle, right? So this is this version as well. Okay, all right, if you click on one, you will get more details, okay? So this is how I explain. It would say the function name is circle. It takes in 3 input parameters. The first one is called point1. This is the name of the parameter, but the name doesn't really matters really. It's the type that matters, okay? It's the type that decides whether this function can run or not, or this command will run or not, or you get an error message. The name is just like a human readable name. And then if you look down, it will specify what point1 actually means. Well, it seems like McNeil kind of messed up with the documentation here. They haven't. So normally you will see like an English explanation of what the point here means. I think this one is kind of obvious, so that's why maybe they didn't even bother to put it in, so it appears as like missing. Okay. If you see the symbol, which means this symbol means that there, if you click on this, you will see some like real code example. If you scroll down, this is the code example in both VB and CSharp. And now recently, they started adding like Python example as well. Can't remember which, okay. Right, should be a positive value. Okay. So that is the circle. Okay, now the circle will be at our point. The radius is going to be 2, all right? Okay, so we get back to our example. All right, now we add the circles to the list of circles. So the list of circles is initially empty, but we run the for loop for like, let's say in this case, 8 times, and each time it runs, it will just add a new circle to the list, okay? So I will say circles dot add a circle. Okay.
But long.
Yes?
When you use the for each, it means that if you run that command each element of.
From the first one to the last one in that order.
Okay.
Yeah.
But if you don't add the list in the end, it will happen the same way, or no? You need.
Oh, this is just for output because if this is to create a circle, but then the circle will not be visible to anyone. You know, you create a circle and you never use it. Okay, but here we use it by storing it in the list of circles, and then finally we output circles to A. And this is very similar to what we did in Python. Empty list, for loop to populate the content of the list, and then we output the list. For each what? For each. So have you set the type upon to list upon 3D? This one, have you right click and choose list and choose the type is point. If it's not a list, you cannot use it in a for each statement. Which makes sense. You cannot like for each point 3D point in mesh, right? And if mesh is not a list, there's nothing to visit. There's no loop to execute.
Why A is out of the for each?
Huh?
Why A is out of the for each?
Because we only want to output one the for loop has finished. Only when the for loop had finished that we have the entire.
So you have inside you get just the last one.
Yeah, you get the last one, but it's in general. So you add the first one, you output the list. You add the second one, you re-output the list, but only the last one will have effect. And then you just.
So outside you get all of them.
Yeah. Well, you get the last state of the list. Otherwise, you will get. Yeah, you only see the last state of the list, which contain everything. Yeah. Remember, things happen in an order. So when you look at the code, you tend to think that everything happens so quickly, and you tend to think in parallel. But if you like go step by step, then it becomes easier to understand why things is in that way. Okay. Now, obviously, if I change the point interactively, then each time I change the point, the C# code will run automatically. Okay. At this point, I want to show you something. If I turn on the profiler, so in C#, in Grasshopper, the profiler will display the time each component takes to run, right? If it's larger than 1 millisecond. If you turn on the profiler display and you don't see a little like red tag here, it means that this component runs in less than 1 milliseconds. All right. So if you go in the code, you don't have to follow this step. I just want to demonstrate. If you go into code and you change something, let's say that I just add an empty line here to force the source code to be different. If I change the source code and I click OK, then remember this is C#, which means that whenever you have a new code or a modified version of the code, or the first time you run the code, the compiler, which is a secret software running in the background, we have to compile it first. Okay, so the first time it runs, it seems to be pretty long because it has to compile the code into this intermediate code, right? But from that point onward, whenever you run this thing again by, let's say, changing the input parameter, it just takes the already compiled code and run, and it's just become less than 1 millisecond. That's why you don't see it here. Now the story is quite different for Python. Python depends on the different implementation and optimization settings, but generally for a language like Python, every time you change the parameter, it just runs from scratch again, as if nothing has been compiled. Because every time it runs, it has to look at the text file and understand that text file as and has no memory from the previous one, for example. Okay, now we gonna do a little example to show you how to use list and the for loop logic. So far we only use the for loop to like do very straightforward things like create circles on the same list, but this time we're gonna fundamentally change the structure of the list quite a bit. So subdivision curve, this is a certain kind of algorithm in computer graphics, which is these days are also like being quite useful in architectural design and architectural engineering as well. So the idea is that can we approximate a smooth curve with just straight line? In fact, we start with straight line, we make the straight line smaller and smaller, and then it will look more like a curve. So in Grasshopper, of course, you know that you can draw the NURBS curve by specify the control points and then change the degree of the curve, and then you get the entire family of the NURBS curve, right? So this is another way to get the curve from straight line. You can approximate a continuous mathematical NURBS curve from a straight line quite easily, actually. So let's say that I have a bunch of input points. Those are my control points, and the order of the control points does matter, so 0, 1, 2, 3, and 4. Now those control points will be input into a CSharp script component as a list upon 3D, okay? Our goal is to, from those points, we're going to generate a bunch of straight line segments, but the straight line segment will be arranged in a way that that they resemble a continuous second degree NURBS curve that you draw in Rhino. Okay, so this is how we do it. We apply so-called a subdivision rule over a multiple iteration. At the 0th iteration, which means like nothing had happened, the result we get is just basically a straight 5 straight lines of 4 straight lines connecting these control points together, and then we output those 4 lines, and we call this is the level 0 curve, so the curve at level 0. And now in order to get to the next level, which is gonna look slightly smoother and more like the curve that we want, we're gonna apply the subdivision rule. We call it the 1/4 3/4 rule, or the Chaikin subdivision rule, because it was invented by a guy called Chaikin, like in 1974, so a really long time ago actually. So this subdivision rule is pretty simple. So for each segment, we're gonna pick a point at the 1/4 location and the 3/4 location of the segment. So basically all of these yellow points here. And then we connect those yellow points together, and this is the level 1 curve, okay? And it's gonna look a bit smoother, okay? Now if you do the exact same thing, take 1/4 point and 3/4 point, connect them together, see how they get more and more like a curve, okay? And if you keep doing that, you will get a full mathematical curve, but you don't have to do it all the way to 100. Okay, so this is how we implement it. Okay, so let's create a C# component. Okay, I think by looking at this, you should be able to create a C# component by now with the input called control points of type list upon 3D. Okay, so type in is upon 3D, and access is a list access, and then the integer called iteration count. Okay, and the output is just called curve. Okay, so let's do that very quickly in Grasshopper. For those of you who just tuned in out, the handout, the slides and the data are in the link in the video description. Okay, so if you want to like follow along and like actually do the example, then it's, you should download those handouts. If you just want to watch, then yeah, you don't have to. You don't have to download those handouts. control points is obviously point 3D, and iteration count is obviously an integer, so it's kind of hinting right there. Make sure that the value that you put into iteration count is no more than 7 for now, because if you put it 10, it will run slower and slower, like at the rate that it gets slower and slower, like exponential. So if you put in 100, it will crash, it will like freeze. So make sure that you safeguard it at 7. And I have 5 control points that I just draw on the screen. All right, so that is the input setup. Let's look at the code. Okay, so at each iteration, we take the current control points, okay, and we generate the next iteration of control points, okay, by using the 1/4 and 1/4 and 3/4 subdivision rule. Okay, so let me walk through the code first. You don't have to type it in. So let me walk through the code first, and then we will have time to either copy and paste it or type it in together. So, so we're gonna create an empty list called new control points. Okay, so and we're gonna populate this list with those new control points of the next iteration. So the control points at first is just a list of red points, right? The point that I draw in less these. Okay, so we take in the red points and we want to generate the yellow point. The yellow points we put it in the list called new control points. Okay. So new control points, empty list, and then we use the for loop. Okay. So for I is equal to 0, I go to the second last positions in the list of control points. The list of control points. Okay. So we visit each segment, and let's say that we currently at segment I. Okay. Segment I, the control point is going to be I, and the next one is going to be I plus 1, right? So from the, if you say control points, it is part of the code. If you say control points I, you will retrieve the actual point 3D at position I in the list control points, right? And same with I plus 1. And from these control points I and control point I plus 1, we can compute the 1/4 point and the 3/4 points, okay? So this is how we do it. So the 1/4 point, so I create a new variable called 1/4 point of type point 3D, and the value of this one is going to be some math. So it's going to be 3/4. So it's going to be a blend ratio between the coordinate of this one and the coordinate of this one, according to the ratio 75% and 25%. Okay, that's 3/4 and 1/4. Okay, so we take 3/4 of the XYZ coordinate of this guy and add to 1/4 of the coordinate of this guy, and you will end up with an XYZ coordinate that lie exactly at 25%. Okay, that's how you blend two numbers together. If you don't know where I get this math from, you can do basic vector math and you will arrive with the same result if you want. That's 1/4 point. And then we add the 1/4 points to the list of new control points, okay, which is originally empty, but as we visit each red segment and compute the yellow one, and we add the yellow one to the new control points. Okay, we do the same thing for the 3/4 points, okay, and then we add 3/4 points to new control points. Okay, and now the control points will be the bunch of yellow points. Okay, but except that I told you we have to repeat this process multiple times, right? So the trick here is we have to execute the same piece of code multiple times, and of course we don't want to copy and paste it. So guess what? We're gonna wrap this thing in a bigger for loop, and the for loop will execute this code multiple times for us. Okay, so before we wrap in the for loop, there's one trick here. We compute the new control points, okay, and then we assign the new control points to become the control points. Okay, and you will see a moment why I do this. This seems unnecessary. We can just like output the new control points, right? But before I do that, I reassign the new control points to be my current control points. I act as I pretend that if it's my starting condition, and you will see in a moment why this line is a problem, because then I can execute the entire thing in a for loop. Okay, so I have a for loop j, and j will run for iteration count. Okay, so the value of j doesn't matter. You see the body of the code doesn't use the value of j. J is just there to count the number of times. Okay, so this thing, whenever this thing runs, it will basically generate new control points and put the new control points back to the control points. And then the next time this whole loop runs, control points will start the next level one. Okay, and then the new control points will be empty again. So you initiate the whole process by you treat the results at the new input to the next iteration. So this one is basically take the input and disguise it as this one take the output and disguise as the input for the next iterations. Okay. And the final step, this is not absolutely crucial. It's just we can condense the code. So here, you don't have to create this variable called 1/4 point. You can just take this whole part of the code, this whole formula, and you write it here directly. Okay. Here I just like start in a temporary variable to make it like kind of clearer to read. But now you understand it. You can just copy and paste it here. All right, so after the for loop run for a number of iterations, and if you read out the control points here, you are gonna see, just a list of points, okay? But we want to draw the actual polyline going through that point. So we need one extra step to draw the actual polyline to output it. So we're gonna draw a polyline, and we're gonna output it into this output part called curve. So that's why I say curve equal to, and then new, because we're constructing a new polyline curve object, so new polyline curve, and the polyline curve constructor command take in a list upon 3D. If you look at the documentation, that's what it does, and then it will give you a polyline curve, which will be output to the output port curve. Okay. So you have the code for reference, but I'm gonna type it in manually because there's quite a lot of logic going on. Okay, so we have a for loop called j that's run for iteration count. All right. So each time this loop runs, we're gonna create a new empty list of new control points. New control points.
Does that have to be J plus?
You're right. That's a good catch. Okay, after you have an empty list, we can visit each segment or each control point in the current control point. So I less than control points dot count -1 because we want to stop at the second last one. The second to last one. Okay, remember the coefficient is like 75 and 25, and for the other point is the opposite, is 25 and 75. Okay, now let's try to draw a second degree NURBS curve using the same control points, and you will see that the middle part of the curve matches perfectly. So I would say, what is the command to draw the curve through NURBS curve? I think just NURBS curve, and we change the degree to 2. Okay, because the subdivision scheme that we are doing give us the degree 2 curve, so change the degree to 2. And if you plug in the same control points, you're gonna see the middle parts like match perfectly. In fact, I will increase the number of control points here to have more middle part. Okay, so if you pump up the iteration a lot, it will run obviously very slow, and it's not hard to use. Probably it's not very hard to see why. So basically, every time we run one iteration, the number of control points double, right? The number of segments double. So the number of segments go up exponentially. So by the time you slide this thing to 20, if you start with only one segment or 2 segments and you subdivide it 20 times, this time you double the amount, you will see that the number go to like a very large number very quickly. So that's why, but in practice, you normally just stop it at like 6 or 7, and that would be usually good enough. You notice that when you draw a curve in Rhino 5, I mean in Rhino in general, or many other software, usually you get degree 3 by default. The setting is set at degree 3. The reason is that this is just like a side note. This is not really like the main C# programming exercise, but I just want to explain why the degree of the curve is usually set at 3 by default. Because just simply because the degree 2 is not smooth enough compared to 3. And what I mean by smooth enough is, if you look at this capsule surface, it is smooth surface for sure, but it's not smooth enough in the sense that if you look at this cross section here, and if you look at the orientation of the surface, this part, the surface, you know, if you draw out a normal vector, they will just like point upward, and the normal doesn't change. So the normal, the rate of change of the normal is 0. Okay, and then for this part, the normal change at a constant speed, right? So if you walk along, you will see that the normal rotates at a constant speed. Then the problem with this is that at the transition between this zone and this zone, the rate of change or the speed of change of the normal vector or the orientation of the surface switch immediately from 0 or no change, because this is like just flat, to a non-zero value, and there's no like gradual gradient. It's just a very abrupt change. So that's why it's not smooth enough. That's why the overall surface is not as smooth, and especially when you do reflection, because you know the normal vector affect lighting and reflection a lot, and especially when you design a car or any shiny objects, or even like the just the shell of your iPhone or whatever product, you want the reflection to look as nice as possible. And if you do this, if you just get a rectangle and you apply round corner, like if you go to Photoshop and you draw the simple round corner, that will be a degree 2 curve or surface, which is not smooth enough in real product design. So this one, if you render, you see like this little, like kind of unsightly, a bit annoying transition between this region and this region. You feel that there's some disconnectivity here. Okay. So even though most people describe, let's say, a typical smartphone as a round corner rectangle, it's actually not. It's not like perfectly round in the sense that you draw a rectangle and you go to Photoshop and you apply a quarter of a corner to it. It's actually more sophisticated than that, because if you produce an iPhone or a smartphone based on that one, it will not look as smooth, or like or the reflection will not look as like nice as you expect. Anyway, so if you're curious and wonder, is there a subdivision scheme out there that generates a degree-free curve? There is. The degree-free curve is slightly more complicated. So each new control point is generated based on free owned control points. So this is the formula. You can try at home if you want. Okay. If you plug it in, you get a degree-free curve. Okay, it's slightly more. It's less intuitive why it will give you a curve in the end. But yes.
When you say degree 2 or 3, you mean the number of iterations that you have? Like
No, that is the iteration count,
Yeah.
and the degree is a difference. So the word degree came from mathematics when degree 1 is a line, because the equation of a line doesn't have any exponential. It's 1, and the parabola, remember, it has the 2 to the power of 2, and degree 3 is the curve. If you look at the formula,
how
it just
many
happened.
flows it uses 3?
Yeah, 3 is the minimum one that gives you the smooth reflections when you in like product design. Well, actually in product design they go to degree 5 in practice to really get smooth. Okay. Okay, and the same principle can be applied to subdivision surface. Rather than starting with a curve and subdivide it, you can start with a mesh and subdivide the mesh to smaller face. So this is starting mesh, and you generate like new vertices, and then you will get a surface that make out of facet or triangle or quads only. Okay, so this is a kind of different approach. So at first, the nerve surface was invented as a mathematical concept. So the nerve surface originally was described exactly by a mathematical equation. This is kind of a reverse approach where you don't have an equation to begin with. You just have a bunch of lines, and then you just like do this ratio blending, like 1/4, 3/4, and then if you draw it over time, it will get approximate to a curve. And there's advantage and disadvantage for both. Like in Pixar use subdivision surface since Monster Inc. They switched completely from nerve surface to subdivision, because for computer animation it has way more advantage. But the problem with this is that if you do in the real design industry, like car industry for example, because car is a real thing, you're gonna produce it, right? You have to subdivide the curve so that its piece of polygons there has to be small enough so that it doesn't look rough in real time. And because if you do a real scale subdivision, you will need so many iterations to get to that level of smoothness. So historically, like subdivision has only been used in animation only, but now, it's also found its way recently to a lot of architectural design project where you see a shell start with simple control polygons, and then they subdivide it to a certain level, and then each of the element here can be converted to, let's say, a glass panel or a curtain panel. So instead of starting with a nerve surface and try to divide it into panels, okay, so like rather than draw a surface and then try to put in architectural elements, you start from the designer specify like basically some control points here, and then the algorithm will give you the architectural elements like as a product. Okay, so it's a different way of like doing surface and paneling design. That's one was invented. So this subdivision scheme is based on this name, Catmull Clark. So these are the two guys who invented this, and Catmull is So now he's like the director, the technical director at Pixar. Okay, so let's come back to the C# programming. Now we have dealing with variable data types, but we have skipped over a very important details. This is very crucial because it's at first it might be hard to understand because this thing happened behind the scenes. You don't really see it, but it's always there. And if you're not aware that it's there, you might get like into accidents and without knowing why it happens in the first place. And that means that you won't be able to fix the problem in your code. Okay. So what is a variable anyway? So I told you a variable is like something that store a value, right? The description of like something store a value is actually quite helpful because it's actually in your computer it's actually a little memory bit. It's like a box, but you know it's just like memory electrons, electric circuit that's actually store a number inside. You can think of it that way. Anyway, so let's look at the example when I create a variable a and I put a number 12 into it. What it does is that it creates a variable a which is a container, okay, a container that has a name a, and the container store the value 12. Okay, so think of a container as a box. Okay, physically it's like a block of memory on your RAM. Think of it that way, but you know mentally you can think of it just like a box or a container. Now, and then when we declare int b, what it does is that it creates a list called b, and then when we say equal to a, what happened is that it takes the value of a, which is 12, and copy it over to this box. Okay, so in this case, when you use the equal operator in this case, it makes a copy of the value. Okay, so now you will end up with two separate independent copy of the number 12 stored in two separate variable, which means that if you modify this variable a, so if you say a equal to 7, okay, it will not affect the other one. Okay, this is like very normal thing, nothing surprising here. Let's look at another example. This is also very normal. If you have a point A and you store the coordinate 0, 0, 0 in it, okay, so it's a box labeled A, and we store the content of the point A in that, and then B, and then if we say B equal to A, it will copy the content that describe the point 3D into this box B, and now we have two separate copy. And now if we modify one of the copy, let's say we modify the z coordinate of this one, it will not affect the other at all. Okay, so it only changes A. So this is the normal behavior. Now things get weird for a certain kind of data types. Okay, so what if this time my data type is a list of string? Okay, now this is going to be a bit odd at first. So when I list string A, so this part create a variable, or again a box, called a box is labeled A. Okay, now the box is meant to store a list of size string. Okay, but actually what is stored inside is not the actual content of the list. The list actually stored somewhere else. So let me explain. So we say new list string. Okay, what happens here? And now this one creates the actual value, which just happens to be an empty list, right? And normally you will think that this empty list will be stored inside this box. Turn out that in this case it's not. The empty list is actually stored elsewhere in the memory of your computer. So that's why I draw it in a little box. And this part is associated with this box by a little arrow here. Now the arrow is just a visual presentation. In real life it's an address. So this is like a memory, like a block of memory. So each block memory has an address, which is like a weird number. You don't even have to know what that number looks like. It looks like your ID number from your passport, but it's uniquely identified where this thing is. And that address is stored inside A. So whenever A needs to retrieve the value, it look into that address, or this arrow here, and see the value. And that's now the reason why it does that is another story. But let's carry on. Let's say that this caused the copy operator to behave differently, because what happened is that when you declare another, okay, so that's the first line, A equal to this empty list, okay, and then you say A dot add the string hello, so it will put the word hello in this list. Okay, so that's nothing surprising there. Now next, let's go to the next line. We declare a variable B, Okay, so B, empty box. Okay, and then we say B equal to A. So what happened here is that it doesn't copy the list to B. It copied the address, the same address that A is storing. So it ends up with an arrow pointing to the same thing. And here's the crucial difference, because now they point to the same thing, which means that whenever you modify this one, the change can be seen in the other one. They're not independent anymore. They are independent variable, but they point to the same thing. Okay? So if I add the terms goodbye to the list, okay, and then if I have a line, extra line here that query the content of the list B will now contain hello and goodbye, even though, you know, at the time we copy it, it only contains hello. Okay, it's very important to be aware. It's kind of hard at first because this thing happens behind the scene. You don't see it when you look at the code. You don't like see this box and arrow, but it happens. Okay. So there are two kinds of data types. The first one is the so-called value type. Value means that when you do the copy, the actual value is copied, and you will end up with two independent copies of the values stored inside two different variables. Okay, so that is the normal thing. So the basic data types adhere, like comply with it, with this behavior. So the integer, double, and same with string actually. And then point 3D and vector 3D, circle. So these are the random common type. So the basic geometry type in random common library is also value type. So whenever you copy them, or you will end up with a separate copy. So the equal operator is just the equal sign. Okay, so when you do the equal sign, it will take the value and put it in the new variable. Now the other one is the reference type. Okay, so what is stored inside the variable is actually not the value. The value is stored elsewhere, and only the reference or the address or that little arrow there, which is just a visual presentation. So that arrow or the address or the reference is stored inside the variable, which means that whenever you do the copy, then the reference is copied, and because the reference is copied, not the actual value, then you will end up with two variables storing two reference, but the reference point to the same thing. Okay, so in effect, it represents the same thing. If you modify one, it will affect the other. And if you copy it to the third variable, same thing happens. You have three variables that represent the same thing. Okay. If you use Python, you might notice the same behavior as well. Okay. All right. So now we can talk about functions and methods. Knowing the difference between value type, reference type, we can, you know, talk about function and methods a little bit. So raise your hand if you have never write a function in your life before in a programming language. Okay, a few. Okay, so I'll be slow. So what is a function? So when your program is really long, there's certain part of the code that you realize that you will need to reuse all over again and again. So rather than copy and paste it, we can package those code in a function and give it a title, and whenever you want to use it, you just like call the name of the function, and that piece of code will be executed whenever you call it. So it's a convenient way to package and reuse the code, and also make the overall program cleaner. Rather than copy and paste, having the same thing lying all around the time, you just package in this piece of code, give it a meaningful name, and whenever you see that name in the code, you know that it will do the thing you want. So defining a function. So first, before you use a function, we have to define it. This is how you do it in Python for sure. And this is the equivalent in CSharp. So let me explain. So a function. Now, where you write these functions, I will show you where to write it in the CSharp component. But let's say that this is we define it. So when you define a function, nothing is being executed yet. This is just like a template code. Okay. Only when you actually invoke it, only then the code will be executed. Okay. So I write a functions that perform this code, and this code basically just compute the area of the cylinder based on the input radius and height. Okay, so this is what a function looks like. This is the name of the function. The functions take in a list of parameter. Now the name of the parameter is, you can give it anything you want. It's just for, you know, so we can refer to it later. So this is radius and height. But most importantly, each parameter must be, must be prefixed by the type. So unlike Python, in explicitly programming language like CSharp, whenever you define parameter for function, you have to explicitly declare the type of that parameter, and you will see the advantage of this explicit typing in a second. Okay, now this functions this is the name, this is the list of input parameter and the type of each input parameter. This function will do something, and then when it finishes, it will return a value. It will give you back a final answer, and that answer in this case happen to be a number, and so we specify that the return value is a double. Okay, so the type of the return or the answer of the function is specified just before the name of the functions. Okay, this is something that you don't do in Python. Okay, but in C#, again, input parameters, you have to specify the type of the input parameters and also the type of the one output. Okay, you can have only one output. You can have as many input, but for output you have only one. Okay, if you have if you want to do multiple output, you have to use some trick, but we're not going to talk about that at the moment. Okay, so these functions, whenever you run it, it will execute this piece of code. Okay, it will take the input parameter, do some math with it, and store it in this temporary variable. So this variable lives inside the functions. Okay, so it's a variable that is declared as part of the function because the function needs this variable to functions to work properly. Okay, and from the array you get the volume. So this is standard math. Okay, and then finally you get the answer you want. You store it in a value, and then you say return volume. Okay, and this value will be returned. Return means that it will just be sent out to whoever use this function. So again, this is not the definition of the function only, not the actual usage yet. So when somebody uses function or in their own code, or well, in this case, they gonna be us, so we're gonna write function and we're gonna use it ourselves. So when we're gonna use the function that we define, this function run, and at the end of the day, we get this value stored in this variable here. Okay. Okay, you will see it more specific in a moment. Okay, so where do we write these functions? Okay. By the way, here I write it in 3 separate lines to make it intentionally long, just to convey the point that the body of the function can be as complex as you want, but obviously you can have return r times 314 times h right away. The body in this case, frankly, can only need to be one line. Okay, and you don't have to like 3 separate lines. Okay, so let me show you where to write the definition of the function, and then after you have a definition, how to actually invoke it or like activate or use it. Okay, so C# component. Okay, we don't deal with the input and the output parameters here. Everything happens inside the code only. Okay, so if you open the code editor, you see something called the custom additional code. This is where you define your custom, the extra function. Okay, so the function, again, the name of the function is compute cylinder volume. Okay, now this function, that's the name of the function. Now the function is expected to return a number as a result, so it's a double at first. Okay, and then in the route pair, the pair route bracket, we're gonna specify the list of input parameters. For each parameter, we specify the type and the name. So double R, that's the radius of type double H. And then the body of the function is enclosed in a pair of curly brackets. Okay. And you will notice that my habit is I always open the bracket and close it immediately before I type in the body, so that I don't forget to close the bracket later on. This is very common. In fact, tomorrow when you do Visual Studio, the code editor in Visual Studio usually like quite smart. So whenever you open a bracket, it will automatically close it for you and move the cursor back to the center. So kind of convenient. Anyway. All right, so only one line, return the volume, and the math is okay, but it can be arbitrarily long. Okay, so this one is like very short, but all right. So this is like how I define the function. Now this code here doesn't run yet. Okay, now to invoke that function, this is what we do. So we invoke the function by type out the function name in the main part of the code. So this is So any code that is written here will be actually execute. Okay. So compute cylinder volume. Okay. And then we open a bracket. Okay. Okay, and then we're gonna supply the real value for the parameter. Okay, so here the parameter is just like a letter. It doesn't have real value yet. It's just a placeholder waiting for real value to be supplied. Okay, and when you supply a value to a parameter, we call it the argument. So the argument is just the value that you pass in the parameter. Okay, so when you see you look at the documentation and see the word argument. So let's say I pass the point 3D that I obtained from the nerve surface as an argument to the function, then okay, the argument is just the value that you send to the parameter. Okay. Okay, and let's say I put in the value 2 for the radius and 2 for h for the height. Okay. Now this whole thing will run behind the scene. Okay. And one is finished running, it will give you a number. So this entire thing that I highlight here, it will be equivalent to a single number at the end of the day, which means that you can store it in a variable of type double. Let's say result. Okay. And then you can do whatever you want with result from now on. You can like do it to compute, air pressure or whatever. In this case, I just want to print it out. Result dot to string. So convert it to text. Okay, so just plug in a panel to the output port so you can see the volume result. Okay. All right. Now let's go back in the code editor. So as I said, first, again, you can condense these two lines of code. You don't need this temporary variable result in this case. So I will just condense or simplify the code a little bit. Okay. So invoke the function. This long line here will at the end of the day will just be a number, and then I apply dot to string to that number. Okay. And I send it to the print command. Okay. Now I can. Because I have the function, I write it once and I can invoke it as many times as I want. Each time I invoke it, I can supply a different argument, a different set of arguments. So now I can compute the volume of a different cylinder who happen to be of radius 4 and height 5. Okay, and I have a different answer. Okay, still the same code that I defined, but with different argument and hence different outcome. The code, yeah. Okay, so again, I make some comparison to Python again in a second. So you might feel it very strict and annoying that you have to specify the type of the return value. Can you say like why CSharp just doesn't guess? Here if I return a volume and here volume is so obviously a double, I mean CSharp can just guess, right? Why do you have to manually specify it? Well, the answer is that it prevents a lot of potential mistake. For example, I write these functions and I know it has to return a double, and accidentally let's say that I forget to have a return statement, or I return a point 3D instead of a double, then guess what? When you press the play button, you will get an error message right away. And not only you get an error message, the compiler will point to the line where the problem occurs. So it points that the functions you claim that it will return a double, but you end up not return anything, or you return a point 3D, and then it will stop you right there, and you have to fix it. Okay. The problem with Python is that you don't specify anything. So if you return a volume, a double, it will return it. If you don't return anything, it will be happy. If you return a point 3D, it will also be happy and run it. And the problem will only manifest itself later in the code. For example, if you call this function and you expect a number to get the volume, and then you feed that volume into a later part of the code to compute the air pressure. Now, if you accidentally return a point 3D here, and then later in the code, that point 3D is being used to compute the air pressure, which causes a problem in the code, right? Because the code expects a volume value, not a point 3D. And at that point, you get a problem, but it's difficult to like trace back to where the problem was.
Why do you have more than one type?
In that case, you use, remember, with Python, you use tuple. Tuple. There is tuple, but the syntax for tuple is quite inelegant compared to Python. So there's another way which I will show you, which is the standard way to return multiple value in CSharp, and also the Rhino Common Library uses this a lot. We will have, I will explain that, and we will also have a live example with curve using that kind of multiple return value. Okay. Huh? The Py, yeah, it's a library math.py, capital M. Capital M, math.py. They should be autocomplete as well. I will talk about a math library later on. I mean, those are quite straightforward concepts. It's just a library. Okay, so from now, I keep calling these functions as commands, but now you know the official name is actually functions, or in C# they always refer to as methods. Those two words are interchangeable. So whenever you read some documentation and they use the word methods, or some other language that use the word functions, they are really just the same thing. Okay. And so the function is always followed by when you use a function, when you activate a function or invoke a function, you always have a pair bracket follow the name, even if that pair bracket contains nothing. That's how you can tell the difference between. That is how you can tell. So this is a function always followed by a pair bracket, even if this pair bracket, like here's a, it's a function as well. It's just that the function has been predefined for us. And this function has a pair bracket. That's why we know it's function. A variable, on the other hand, never have a pair bracket. Okay. All right. So a good naming conventions. Variable names usually is a noun because it describes an object, okay? But function name always should contain a verb. So here, rather than say string, it say toString, so it imply an action, okay? And here, rather than say cylinder volumes, which imply a noun because it imply a variable name, I actually put in the word compute to emphasize the fact that this is the function, this perform an actions, okay? So that's pretty standard guideline as well when you choose the name, okay? If you don't have a better word to describe the action, I use compute, calculate, or get. So for simple code like this, normally you use the word get. So get is by convention, not convention, but more like common naming habit of programmers around the world. If you have a very simple function, you use the word get. If you have something really intensive, you tend to use the word compute. So that the person who reads the function have the hint of like, if the function has a compute word into it, the person who uses it will know, okay, this thing gonna be intensive. I should not use it too much. I should not put it in a for loop and make it run like a million times. Okay, but function like get volume or get length for a vector, you can run it a million times, no problem. Okay, so that's something to keep in mind when you choose a name for functions. Okay. Now, this is another example. You can have a function being invoked in the body of another function. So let's say that compute the cylinder volume. Okay. Actually, this is not a good example to use it, but in the code here, I already use another function. Let's say that during Okay, in order to compute the volume, let's say I have another function. You don't have to follow this step, okay? I just want to like do a quick demo. So compute circle area. This one take in a radius, okay? And this one is simple as well. So we should say just return r times 14. Okay. Okay, so this is another function. I can invoke this function in the main part of the code, sure, but I can also use this function here. Okay, so let's say that this part. So the instead of like rewrite the same math, I can reuse the math I've established earlier on. So I would say return. So I can do it 2 lines here slowly. So I can invoke the circle area, compute circle area function. Okay, I pass it in the value, and the value comes from this one. Okay, so my parameters going to become the argument of this child function. Okay, this one will return a number, which is the area, so it's called base area. So, okay, and then I multiply the base area with. Okay, so you see by reusing function, you can like make your code very elegant. So rather than imagine like rather than like writing out this full math, whenever you want to compute the area of a circle, you just package it in a piece of code, a function, give it a meaningful English name, and then whenever you see it, you know exactly what it does. Okay, so even if you like didn't go to the elementary school and you didn't know that this is the formula to compute the area of a circle, by looking at the name, you know that it's the area of a circle, even if you don't remember the math. Okay, so and in this example, of course, the program is simple, so it's not immediately obvious why this thing is good. But imagine if you have a large program, by like package each part of the code into like separate module with a meaningful name, it makes the code reusable and easier to understand as well. And sometimes you don't, and sometimes you don't even need to understand what's going on. So so the one extra benefit of the functions is that a function is like a black box. Okay, so the person who writes the definition of the function must fully know the details how the function works in order to code it up. But if you share this function to your friends and your friend use it, then your friend doesn't need to know what's going on. Your friend only needs to know that it takes in a double for the radius and a double for height and return a volume. Your friend doesn't even need to know the mathematical formula to use it. Okay, or if you have a very complicated function that, let's say, work out the path of a robot, if you give the function to your friend, you say, as long as you give me the starting point of a robot and the constraint, I will output the right path. Okay, then your friend doesn't even need to know what's going on inside the function. So when you read a large program, it helps you understand when the program is written in a modularized level with a lot of functions, where you don't need to understand every single detail, but you still have a good like high level understanding of the whole program. Okay, so that's easy. Okay, so now this is the next concept related to functions, very important because this appears all the time in the Rhino command, so you need to know this to use it correctly. And this is also come into play when you use R in Python as well. This is something that you can't define Python, but you can use it in Python. So it's a bit odd, but let me explain. So let's imagine I have a complete cylinder volume, but I want to make 2 different versions. The first version accept a radius and a height and do this math. But there's a scenario where you want to define a complete cylinder volume that take in the radius, but not the height directly, but take in the point 3D that represent the bottom center and the top center. Okay, and then internally they can use the bottom center and the top center to work out the distance. Okay, and use that as the height. Okay. Anyway, so the way to do this is that you give different name for the functions, like compute cylinder volume 1, compute cylinder volume 2. But this is annoying because whenever it's supposed to do exactly the same thing, but just like with slightly different variations. And if you have to keep coming up with different name for it, then it's kind of annoying, and also for both the person who writes the function and for the person who going to use the functions. So C# supports this feature called function overload, where it allows you to have multiple versions of the functions. So see, if you define a function with the same name but with different list of input parameter type, okay, it will happily accept it. So these two functions, same name. I remove the 1 and the 2. I don't need to like keep coming up different name for it. Okay. They are different in the input. Now, they are different not in the name of the input parameter. The name is just for human readable. They play no role in the actual distinction of the different version of the functions. It's the type. Okay, so this is a function taken in a double and a double, which is clearly different from the same function with the same name, but taken a double upon 3D and upon 3D. Okay, so when the person who actually uses functions, and depends. So when you if I invoke this function in my part of the script and I give it two double, then of course it will know that it should use this function. Okay, if I supply a double and 3 pawn, it will automatically can figure out just by looking at the type that you supply to it. It will match it with the right version. Okay, this is not, you cannot do this in Python because in Python you don't declare the type of the input parameters. So that's why there is no way for Python to know which data type that you want. So, but it's very important in C#. Okay, so this is a sample where I used I call compute cylinder volume. I give it 2 numbers, so it automatically knows that it should use this version. Okay, this is the one I use, the second version, obviously. Now, what if it cannot? Okay, so this is just behind the scene a little bit, so just to help you understand the error message better, because you're gonna see this error message a lot when you type C# code, and the same for R and Python code actually. So a functions. I'm talking about different version of the function, right? And a different version is uniquely identified by the so-called signature. So what is the signature? The signature is basically a makeup of the function name and the type of the input parameter. So this line, by the way, is not C# code. It is just like a notation that describes the signature of this function. So signature is the name and the type. Okay, so the semicolon is irrelevant here because this is not really C# code. Okay, so this is the signature of this function, and this is the signature of this, well, of the same function but another flavor or another version. Okay. Now you notice that the return type plays no role in the signature because the signature is something that can be used to uniquely identify the function when you invoke it. Now when you invoke it, you don't specify the output, right? So there's no way you can tell which version you want to use by looking at the output. Only by looking at the name and the input that the C# language or the C# engine can know exactly what the person intentions is. Okay. So the two functions. So all different flavors must have different signatures, and the signatures is again only identified, is decided by the type of the input parameters, not by the name. So if you define, like if you overload a function, so if you overload a function definition by giving it 2 versions that have the same signature but only difference in the variable name, then this is illegal, and probably it's clear why, because changing the parameter's name like does nothing in order to separate this function from this function when you invoke it. When you invoke it, you give it, when you invoke this function in the main script and you give it two real number, there's no way C# will know which one you want to use because they look the same. They will accept 2 doubles, right? So the name of the variables play no role in deciding the actual flavor or the identity of the functions. So this one is illegal. You will get an error message. If you try to run this code, you will get this script, this C# script already defines a functions, or it's called a member here, which is kind of weird, but it basically it's already declare a member functions called compute cylinder with the same parameter types, or the same parameter type, which is like namely two double. Okay, so you will see that error message quite commonly. Okay, this one is not legal either, because this one have the same signature. They only different by the return type, but as I told you, the return type plays absolutely no role in uniquely identifying the different version of the functions. Okay. In case that when you try to invoke a function, and let's say that okay, you define two functions. The first one taking the double point 3 and point 3, and then when you invoke it, you don't supply anything. So basically, you asked C# engine, the C# engine, to fight you to get you a version of the compute cylinder volume whose parameter is empty. Now, of course, this one doesn't exist, so the error message will look like this. Say that no overload method or no overload function for compute cylinder that take 0 argument, because it could not like find anything that match the parameters that you specify. Okay. So basically, it say that your code is wrong, but the way it say it takes 0 argument, it sounds very cryptic. But if you see it, you kind of understand what it means now. And I guarantee you're going to see it a lot, even if you use IronPython. Okay. And now, understanding function overloading, we can easily get back to the Rhino command documentation. Now, I've been talking about the constructor command. Well, now command is just a function. So constructor function it's just a functions, but it's special because you always have to put the keyword new in front of it. Okay, but it's a function nonetheless, which means that it can also be overloaded. Look at this circle constructor function. Okay, so the name is circle, but the list of parameters, they have actually 7 different flavors. And each different flavors, they do the same thing. I mean, they will give you a circle, an actual circle value at the end of the day, but the input parameters they take in are different, and then they're different not in the name, but in the type of the data type of the parameters, of the input parameters. Okay, so that's why if you look at the signature here, you don't even see the name of the parameter. You just say that the first parameter is a plan, the second is a double. Okay, but the name, I mean, doesn't matter. All right. So in IronPython, weirdly enough, IronPython, you cannot define an overload function for obvious reason, right? Because I say that because IronPython does not work with explicit type, so you can there's no way to like tell that the distinguish between them. However, if that function was already defined in C#, so in the case of Rhino common, the function was defined in C# and it was overloaded in C#, you can still invoke it in IronPython. You cannot overload a function in Python, but you can use a function that has already overloaded in C#. So that is why when you use IronPython, you can still access different functions of the circle constructor. Okay, and depends on if you throw it in a point 3, it will invoke the right overload method. Okay, but this overload method was written in C#, that's why it was possible in the first place. But if you try to write a definition of overload function in IronPython from scratch, it's not possible. You will get an error message say that the function name circle has already been defined. Okay, so it's important to know. All right. Okay, so there's a lot of things, and we've talked just a lot of theory without any explanations, without any live example, because there's really no live example there. Now, parameter passing. Now, this one is also important because this it's important and strict at first, again, because this thing happened behind the scene. But I think, yeah, we should break for lunch before we get back to this part. So let's carry on at 2:30, okay?